Question 22. A ball of mass m is attached to a string of length L. The ball is swung in a vertical circle as shown below. The string breaks at the top of the circle and the ball is projected with a horizontal velocity Vx of 5 meter per second. Calculate the time of flight of the ball given that in part A the length of the string is 1 meter and in part B the length of the string is 1.5 meter. So here in this question you have a ball of mass m being swung in a vertical circle with the help of a string, and the length of the string is also the same as the radius of the circle. At the top of the circle the string breaks and the ball is projected horizontally with an initial x velocity, which is given as 5 meter per second, and then the ball follows a parabolic path falling down on the ground, and we need to find its time of flight, which is the time it takes to fall back on the ground. Now this is an example of a horizontally launched projectile, and we know for a horizontally launched projectile the initial y velocity Vy0 is equal to 0, whereas the x component of velocity remains constant throughout the motion. So whatever initial value of x velocity you had, that will be the same as the final x velocity. Since the ball was released from the highest point in motion, the height h from which it is falling will also be equal to the diameter of the circle. And you can find the height h by taking the diameter, which is nothing but 2 times the radius, which is 2 times L. And in part A of the question, this length L is equal to 1 meter. So the height from which the ball is falling will be 2 times 1, which is 2 meter. Now this height is nothing but my displacement along y-axis. And since the ball is falling, this displacement delta y, which is equal to y minus y0, we will have to take it negative. Negative because it is falling down. So my delta y will be equal to negative 2 meter. We need to find the time of flight t. So now I'm going to use the equation of motion to solve this. We will use the first equation of motion, which says y minus y0 is equal to v initial t plus half at squared. We are using the y component for this equation because we know what is delta y, we know what is initial y velocity, and we know the acceleration along the y-axis, which is equal to acceleration due to gravity g, that is equal to negative 9.81 meter per second squared. So let's substitute. Y minus y0 we will take as negative h, which is negative 2 equals Vy0 is 0 here. So anything multiplied with 0 will give me the entire term as 0 plus half. A is negative 9.81 t squared. Solving further, we get negative 2 to be equal to negative 9.81 over 2 times t squared. So we can rearrange to write for t squared to be equal to 2 times negative 2 over negative 9.81. Now take square root. T will be equal to square root 2 times negative 2 over negative 9.81. That gives me the time value to be equal to 0.64 seconds. Now you can also solve this problem using a simpler rule. For a horizontally launched projectile, the time of flight t is given as square root 2h over g, where h is the height from which the projectile is falling and g is acceleration due to gravity. And anytime you apply g value to a rule, you don't need to substitute it as negative, because while arriving at this rule, we already took all the quantities which were negative in our equation. So no need to rewrite them. So we get this as square root 2 times h. H here is 2 meter over g, which is 9.81. That will give me the same value, 0.64 seconds. Now for part B of the question, I'm going to directly apply this rule. So for part B, my length L is 1.5 meter. And we know that this length L is equal to the radius of the circle. So the height through which the ball is falling will be equal to the diameter of the circle, which is 2 times L. So height will be 2 times 1.5. That gives me h to be equal to 3 meter. So I can find time of flight t as square root 2h over g, which is equal to square root 2 times 3 over 9.81. That gives me time of flight to be equal to 0.78 seconds.